Okay, so we're going to start over here. It says draw a blank through the equal sign, a line through the equal sign to separate two sides. Locate the variable. Use inverse operations on both sides of the equation to isolate the variable. Undo addition or subtraction first. Undo multiplication or division last. Check your answer. Okay. Inverse operations. Okay. It is the opposite operation. Okay, so if I have addition, the opposite operation is subtraction, and vice versa. If I have multiplication, the opposite or the inverse operation is division, and vice versa. So if I'm looking at this, the first thing I do is draw a line down. Then, this is my variable. Right now, I have a 2 multiplied, and I have a 7 that is added. So it said to get rid of addition or subtraction first. So that means I'm going to subtract 7 from both sides of the equal sign. This is the subtraction property of equality. And it says, if I subtract on one side of the equal sign, I must do it on the other side. So I bring down the 2x because these two cancel out, and I get 8. Then I want to isolate the variable, so I need to divide both sides by 2. When I divide by 2 here, I get a 1 in front of the x, but we don't write that 1. And 8 divided by 2 is 4. We did the division property of equality. Then we check our answer and make sure it's correct. So 2 times 4 plus 7, does that equal 15? So multiplication comes first, so I multiply. And 15 does equal 15, so I did get the correct answer. Okay. What you do to one side of an equation, you must do to the other side. Sorry, I didn't know that was there. So here we go. I'll draw this down. I get rid of addition or subtraction first, so I have to get rid of this first. So the opposite of it adding 6 would be subtracting 6. So I do that to both sides of the equal sign. I get equals 4. Then, this is division right here. This is division. So the opposite of division is multiplication. So I'm going to multiply both sides by 2. These 2's cancel out, and I'm left with m equals 8. So then I check my work. 8 divided by 2 plus 6, does that equal 10? Well, 8 divided by 2 is 4, plus 6. So 10 does equal 10. So that means that I do have the correct answer. Then I come over here. Again, I draw my line. This right here, I get rid of addition or subtraction first. So the opposite of a subtracting 3 is adding 3. So I get 2x equals negative 2. I divide both sides by 2, and I get x equals negative 1. So then I plug it back in. 2 times negative 1 minus 3, does that equal negative 5? Well, 2 times negative 1 is negative 2. I have 2 negatives and I have 3 negatives. I have a total of 5 negatives. So yes, I have the correct answer. So x equals negative 1. So here again, I draw the line down. This is addition, so I want to get rid of that first. So I subtract 5 because 5 minus 5 gets 0. So we're trying to get the variable by itself. So negative z over 3 equals 4. Now, this right here, this negative z over 3, guys, just think of it as the whole fraction is negative, because that's what it is. I'm going to multiply by negative 3. Multiply by negative 3, because negative times a negative gets a positive. Negative divided by a negative gets a positive. So those negatives are going to go away. So the negative 3, that cancels out, and I get z equals negative 12. I plug it back in. I have negative 12 plus 5 equals 9. Okay? Oops. So negative divided by a negative, those turn to positive. So that's 4 plus 5. So that gets 9 equals 9. So that works. So my answer is z equals negative 12. Okay, so let's try these down here. Okay, here we go. I add 10 to both sides, because that's the opposite of subtracting. I get negative 4x equals negative 24. Then this is multiplication. The opposite of multiplication is division. So I get x equals 6. Then I plug it in to see if it works. So negative 4 times 6 minus 10, does that equal negative 34? That's negative 24 minus 10. So yeah, negative 34 equals negative 34. So yes, I did the right work. So let's come over here. So I'm going to subtract 19 from both sides. I get x over 7 equals, this is the same thing as like saying 19 minus 4, which would be 15, but there are more negatives than there are positives, so it gets a negative 15. I'm going to multiply by 7 because that's the opposite of division, and that's going to come out to be a negative. That's a 5, 3, 7, 105, negative 105. So then I plug it back in to make sure that I'm doing the right work. So negative 105 over 7 plus 19, does that equal 4? So this would get me negative 15 plus 19, does that equal 4? Yes, it sure does. So that means my answer is correct. Oops. Okay, so now let's do this one. I want to get rid of this right here, so that means I do the opposite of adding, which is subtracting. Get negative 5c equals negative 25. Divide by negative 5. And c equals 5. So I check my answer to see, oops, that's the wrong color. To see if it's correct. So negative 5 times 5 plus 9, does that equal negative 16? Negative 25 plus 9. There are more negatives than positives, so the answer is negative. 25 minus 9 is 16. So yes, we do have the right answer. C does equal 5. Okay, let's try this one. Oh no! The variable's on the other side. That's okay. We're still gonna add 9 to both sides. There are more negatives than there are positives. And I subtract those numbers and I would get 15 equals x over negative 5. Multiply both sides by negative 5 because that's the number sitting under x. And that would get me, let's see, 75 is equal to x. So then I plug it back in to make sure that I'm doing the correct thing. 75 divided by negative 5 minus 9. That's negative 15 minus 9. And look at that. It came out to be the correct answer. Okay, again. The opposite of this, the opposite is adding 12. So I'm going to add 12 because we want it to make 0. So I would get 20 is equal to 5y. This is multiplication, so I'm going to do the inverse operation, what is division. So 4 equals y. I plug it in to make sure that it actually works. So 8. Is that equal to negative 12 plus 5 times 4? So 8, negative 12 plus 20. 20 minus 12 is 8. So yes, we have the correct answer. This one, again, bring this down. This is addition, so I would subtract. I get 1/3 t is equal to 2. Then I would multiply both sides by 3. Cancels. T equals 6. So I plug it in. 1/3 times 6 plus 2, does that equal 4? So this would be 6 over 3 plus 2 equals 4. That would get me 2 plus 2. That is 4 equals 4. That does work. So t equals 6. Okay. So I want the b by itself, so I'm going to first add 17 to both sides. And that's going to get me 30 is equal to negative 5b. I divide by negative 5. Positive divided by negative is a negative. So then I plug in and make sure I did it correctly. Negative 5 times negative 6 minus 17. So 30 minus 17. Ooh, look at that. Did I do something wrong? Look at that. That comes out to 13. I didn't do it right. Ooh, so I have to try again. There's something that's went awry. What did I do wrong? When I added these two together right here, that's not 30. That's 35. I divide by negative 5. I get negative 7 equals B. Now let's try it again. See if I did it correctly this time. 18, does that equal negative 5 times negative 7 minus 17? 18 equals 35 minus 17. 18 equals 18. So negative 7 is my answer. And no, I didn't do that on purpose. I actually messed up. Oh, fractions. Fractions are our friends. Okay, so I add 1/2 to both sides. I get x over 8 equals, so negative 7 plus 1 is going to get negative 6 over 2. And hopefully, boys and girls, that you know that that's negative 3. I multiply on both sides. Oops, let's bring this down a little bit. Multiply by 8, and I get x equals negative 24. So then I get negative 24 over 8 minus 1/2 equals negative 7 over 2. So negative 4, nope, try that again. Negative 3 minus 1/2 equals negative 7 over 2. Well, there's several ways I could do this. This is negative 3.5. And if I was to rewrite this as a mixed number, that would be negative 3.5. So it does work.